Hi everyone, in this video we are going to learn about MACD. You will learn about the various steps involved in the calculation of the MACD histogram in Python. I'll also teach you how to code this up in Python and also to backtest this trade using MACD, and we will look at the returns under various market conditions, whether it's sort of good market conditions or bad market conditions, and we will see in each of these cases how using the MACD helps us beat the buy and hold strategy. As usual, the download link to the notebook will be in the description below, and let's jump right in to the MACD. So what is the MACD? The MACD represents sort of what I call a second order indicator of bullishness, and we will start with using the Bitcoin data, and then this is 5-minute Bitcoin data, and this is the price action, and we will start here, and then we will look at how to calculate the MACD. Let's first visually look at how to step-by-step calculate the MACD, and then we will look at how to do this in Python. We start by looking at the price action here, and then we take the next step, which is to calculate the first and the slow moving averages. The first and the fast and the slow moving averages here are the exponential moving average and not the simple moving average, as we have looked at in the previous videos. So if you look closely at this graph here, these are the candlesticks here, and then you look at the black line here represents the fast moving average, which you can see is sort of hugging the price line here. And then there is the blue line, which represents the slow moving average, which you can see is sort of more removed from the exact price line, but represents a longer term average of the prices. And what we want to see is the difference between the fast and the slow moving averages. So step 1, we have calculated the fast and the slow moving averages of the data, and then step 2, we are going to look at the difference of the fast and the slow moving averages. And as we already know, when the stock is bullish, the fast moving average is larger than the slow moving average. So if you look closely at this price action here, you can see that there are these regions when the stock is bullish, and these are the places where the fast moving average is larger than the slow moving average. And then there are the cases where the price is bearish. This is a region where the price is bearish and the fast moving average is lower than the slow moving average. So the price is sort of below its average value over a longer period of time. So now we jump to our second step, where we look at the difference of the fast and the slow moving averages. Clearly, this is an area of downturn, and correspondingly, we can see that the fast and the slow moving average difference is negative. Now, this is an area of the uptrend, and if we look at the difference of the fast and the slow moving average here, those numbers are positive. So that's sort of intuitive here. In our step 2, we have calculated the difference of the fast and the slow moving averages, and we intuitively understand where it's positive and where it's negative. It's negative where the price action is bearish, it's positive where the price action is bullish. So now we go to step 3. In step 3, and this is where it gets a little more complicated, is where we calculate a moving average, in this case an exponential moving average of the MACD line. So the MACD is simply the difference between the fast and the slow moving averages. Now look at step 3, and let's zoom into the plot here. You can see two lines here. The blue line here is the MACD, and this is the difference between the fast and the slow moving averages that we calculated before. The yellow line here is what we call the signal line, and this simply is the exponential moving average, which is sort of a smoothed out version of this line. As you can see, this blue line is sort of jagged, and the yellow line is sort of a more smoothed out version of this jagged line, which is a exponential moving average of the difference between the fast and the slow moving averages. Now the MACD histogram, which is sort of the most common thing that you will see charted in any charting software. If you're using like TradingView or some other charting software, this is the plot that you're going to see, and this is sort of the final step of our calculation, where we are going to see the difference between the fast and we're going to see the difference between the MACD line and the signal line. So if you look closely at this plot here, so if you look closely at this plot here, there are these areas where the MACD is increasing at a fast pace. And when the MACD is increasing at a fast pace, this is when sort of the difference between the fast moving average and the slow moving average is increasing at a very fast pace. And what this means is that the bullishness is increasing. This is sort of a second order view of the bullishness. The difference between the fast and the slow moving averages is the first order view of the bullishness, and the rate of their increase is sort of the second order view of the bullishness, and this is what is captured by this difference. And when that happens, we observe that the MACD is positive. Now look at the second case where the difference between the fast and the slow moving averages is decreasing fast, really fast. Example here. And this is a case where the MACD histogram is negative. And I hope that sort of visual explanation provides us with the required explanation for what is the MACD. And now that we know the MACD sort of histogram, let's see how to calculate these visualizations in Python. So let's go back to our notebook here. Just to recap, we always start with a Bitcoin 5-minute data set, if you are familiar with my previous videos, and this is a data set which has 5-minute intervals between consecutive sort of data points, and we look at the price of Bitcoin at sometime around July of 2024. Now this calculation, so of course the MACD calculation requires 3 variables: the short window, the long window, and what we call the signal window. First I do an illustrative calculation which helps to show you the visualization more clearly, and then we use the more conventional sort of values for the short, long, and the signal window afterwards. But this is just to give you an illustration. But nevertheless, we start with this data frame here, which our original data frame contains open, high, low, and close for each time period. Those are the main ones. The location index is kind of a, it just has numbers from 0 to n just to help us plot, and then there are some more other variables for visualization help, such as what the time string is and so on. But we start with, for our calculations of MACD, we start with the short EMA, and we calculated using the exponential window moving function in so this is sort of the exponential window function in pandas, and then on that exponential moving window function you can calculate the mean, which is the exponential sort of moving average, and that is what we calculate here, and then we give it the short window and the long window as arguments, and that helps us calculate these short and the long moving averages. So going back to our figure here, this is step 1 of our calculation, where we calculate the fast and the slow moving averages. So once we have done that, we calculate the MACD, which is simply the difference of the short and the long moving averages. And this is step 2 of our figure here, where we calculate the difference of the short and the long moving averages. And then the third step where we calculate the signal line is simply, again, we take a exponential moving average, which is the same formula as before. This time we take the exponential moving average of the MACD. So this is step 3 here, where we calculate this orange line by taking the exponential moving average of the MACD line. So those are the main steps. And then we take the final step where we make the histogram plot, and we say that the histogram is simply the difference of the MACD and the signal line. And then that helps us make a bunch of plots. And these are the plots that I went through with you for visualization. This is simply the price action. And here we sort of plot the price action. And on top of that, we plot the fast and the slow moving average. And you can see that here in this plot. And then in a separate plot, we plot the MACD, which with our location index, which is this blue line here, which is simply the difference of the fast and the slow moving averages. And the final plot is the histogram, which is the plot you see in this function called make MACD plot. We can sort of go through that plot. Yeah. So first we calculate the difference between the MACD and the signal line. And then we calculate this histogram, which is the bar plot, which shows sort of the histogram. And with a green line if the value is larger than 0, or a red line if the value is less than 0. And then we sort of have a 0 line for the reference, and then we just set the labels and the titles and so on. So that's kind of the basic explanation of how we calculate the MACD. So now let's sort of backtest some trades with the MACD. So here is, again, here is the default numbers. So if you go to a charting software, you will see that the default numbers that are always used is short window 12, long window 26, and the signal window of 9. We can look at what happens if we sort of change it to those default numbers. So we get sort of a more granular MACD, which changes values a lot between the short and the long, sort of between the green and the red, and it's harder to sort of visualize, which is why I went to the illustrative plot. And here you can sort of see the orange, the MACD, and the signal lines for the default calculation. So now let's come to the backtesting part of our video. So as you know already, in most of my videos, I show how to backtest some of these strategies in Python. I use my own backtesting library, which I will link to in the description below, as well as on the video. And you can see how we built the backtesting library. But for the convenience of our viewers, basically our backtesting library implements some sort of a strategy. So the simplest strategy is a random strategy, and and the implementation of a strategy simply means that we say when to buy a stock. We sell a stock only when it profits or loses. So I can go to that. Yeah, so we always try to close a trade if the current candle value is less than the stop loss value, or if it's larger than the take profit value. So that is always our exit condition. And each strategy sort of differs on what its entry condition is. And for a random strategy, the entry condition is if a random variable is 1, then we sort of buy if we have enough money. And then we define here as the MACD strategy. The MACD strategy has a different entry condition here. So it just says if the MACD histogram is larger than 0, which means that we are in the green part of the histogram, and then we just add it to our random condition. So if the random variable is larger than 0 and the MACD indicator is larger than 0, or MACD's indicator is true, then we buy. So we first look at what happens when we do this in our on the visual on the chart that we visualize. So this is the price action which we visualized. So we make an entry based on the MACD. So we start with a cash of 70,000, which roughly allows us to buy 1 Bitcoin at a time. which when the Bitcoin price was around 66K. And then we sort of run this strategy, and we observe that if we just bought and hold at this period, we would have had a 3% return, but with the MACD strategy, we see like a 4% return. So this is the visualization of all the trades we took with the MACD strategy. In this case, I don't think the visualization adds a lot to sort of any intuition about when it did the buy and sell. What makes things more clear is if we try a larger time frame. So that's what we did here. So this was based on, so our first sort of iteration was this small df was based on 1,000 data points. Now we are looking at a second sort of data frame which has 5,000 data points, which should give us a better idea. And here we actually see, so this is what happens with a random strategy if we just buy and sell randomly. Here we observe that the MACD with these sort of window values is doing better than the random strategy, but not better than the buy and hold. And the next step that we take is to optimize this strategy. So we have this optimization function, and I have a separate video about how to build an optimizer, which you might want to look at, and I'll again link it in the description below and in the video itself. And we basically optimize stop loss and the profit percentages, and then the MACD specific variables, which is a short window, long window, and the signal window. And the idea is, so this is a constrained optimization. So if the short window is larger than the long window, which we never want, we just return minus infinity. So we will never choose a condition where this happens. And then we just return the percentage return if we use this short window and the long window. And let's see. And so we go through 250 steps of the optimization, and that returns our best parameters, which says that choose a short window of 18, long window of 26, and a signal window of 12. So this kind of shows you that it's not always useful to choose like the default values that the trading software gives you. And that's the power of sort of using Python, is that you can sort of, run your own optimization program and choose your own parameters. And even if you're using like TradingView, you can sort of use these parameters instead of the ones that are supplied by the software itself. So what happens when we use this optimized parameters? So we just plug in these optimized parameters and then test this 5,000 data points here. And here we observe that our returns have improved a lot. So at this position, our buy and hold return would have been minus 8%, but our return is now like minus 1%. Someone raised the question in one of my previous videos that your return is negative here. But remember, my goal is not to show you sort of very, exorbitant returns. My goal is to show you how to create strategies that are beating random strategies, that are beating buy and hold. So these strategies are intelligent strategies. Having said that, we've tried other strategies on the same data set which have given us better returns. So I think that the MACD, using the MACD by itself, is not going to be the best indicator. It is definitely going to beat the buy and hold and the random strategies, but ideally you would want to use the MACD with some other indicators, and that is something I plan to show in a future video, hopefully. Hope you enjoyed this presentation and hope you learned how to calculate the MACD, the steps involved in it, and how to do that in Python, and how to backtest this code. Please like and subscribe my videos if you find this useful, and I can continue to make more content about Python trading strategies. Thank you.